afternoon, everyone. Welcome to the live webinar on scaling campus Wi-Fi, real-world challenges and lessons from live deployments. I'm Mansi Taneja from Economic Times Telecom, and I have with me Mr. Nadeem Akhtar, Senior Vice President, Product Line Management at HFCL. With over 20 years of experience in the telecom industry, Nadeem has worked extensively across Wi-Fi, 4G, and fixed wireless access technologies. At HFCL, he leads the wireless and switching R&D team. He holds a PhD in mobile and wireless communication and has also authored multiple research publications and filed patents in the field of wireless communications. Later in the webinar, we'll welcome a spokesperson from a global organization for a special presentation, Mr. Tiago Rodrigues, who is President and CEO of the Wireless Broadband Alliance, where he leads strategy, operations, and industry programs to advance Wi-Fi market opportunities. Before we begin the webinar, let me set the context quickly. The education sector is in the midst of a significant digital transformation. Today's students expect uninterrupted access to learning resources, applications, and services from anywhere on the campus. Faculty members increasingly depend on digital collaboration tools, hybrid learning environments, AI-driven platforms, and immersive technologies to enrich teaching and learning outcomes. At the same time, institutions are challenged to enhance student experiences, foster innovation, and improve operational efficiency. In this webinar, we'll explore how campus networking requirements are evolving. We'll draw insights from one of the India's largest university Wi-Fi deployments by HFCL and discuss practical approaches to building secure and scalable and future-ready digital campuses. Now, let me invite Nadeem to give a presentation. Nadeem, over to you.
Thank you, Mansi, for the kind introduction. As Mansi mentioned, we are today going to talk about scaling campus Wi-Fi. Specifically, we will be talking about what is campus Wi-Fi, how it has evolved over the years, and what are the challenges, requirements. And we will have a case study based on one of the largest campus Wi-Fi deployments done around the world by HFCL, and we'll share our learnings from this experience with you all. So welcome to this webinar. So before we go into the solution and other aspects, let me take a step back and talk about what is the market landscape that we are referring to here. So here, if you look at the Wi-Fi in education market, we can broadly categorize into three different segments. So there is a preschool market, there's a K-12 market, and then there is a higher education market, which essentially comprises colleges and universities, etc. So today we are mostly going to focus on the higher education segment. Nevertheless, if you look at the market itself, overall, the global market by the end of 2024 had grown to 7 billion, and with a growth rate of 18%, we are expecting to reach 36.5 billion by 2033. So there's a significant market to be exploited in this area, and the campus network market, which is targeting the higher education segment, forms a substantial part of this whole business that we are going to talk about. So what is changing or has been changing over the last few years, especially in the post-COVID era? There are three, I would say, key drivers that are leading this transformation. One is there is a shift from the old school thought of, class whiteboard and notebooks and so on to a digital classroom-based infrastructure where the classrooms are equipped with state-of-the-art EdTech capabilities to enhance the learning experience. And second is, just like every other part of our life today, AI is transforming the way education is delivered and education is received. So AI-driven platforms are becoming an integral part of the learning process across campuses. And in order to take advantage of these new technologies that are becoming part of the classroom, students are encouraged to bring their own computing devices into the classroom, into the hostels and the campuses, so that they can leverage the new ways of teaching and learning. So BYOD, or bring your own device, is another key trend that is driving how the campus network is evolving over not just in India but across the world as well. So how, if you go back, let's say 3 or 4 decades, campuses were primarily connected over wired Ethernet, and that time, if you go to the 80s, for example, 1 Mbps Ethernet was the most prevalent form of connectivity. And as a result of that, internet connectivity itself was some kind of a privilege. So network connections were available in limited places, for example, faculty offices or central labs or computer centers where students had to go and access internet or other capabilities of the campus network. With the advent of Wi-Fi and multi-gig Ethernet, we started seeing more widespread deployment of campus networking, in the sense that the footprint of the network increased, especially with Wi-Fi, and you could find Wi-Fi access points deployed in common areas like departmental labs, libraries, and hangout spots like campus cafes. And wide Ethernet also expanded its reach, going all the way up to hostels. But with later generations of Wi-Fi, where high-speed Wi-Fi became, a reality, especially with 11N, 11AC, or you call it Wi-Fi 4 or Wi-Fi 5, they started a trend towards creating carpeted Wi-Fi networks, which covered the entire campus, including classrooms, hostels, corridors, all the common areas where students and faculty gather and take part in the learning process. So the bottom line is that in today's campuses, Wi-Fi or the network access is as important as uninterrupted power supply or any other basic amenity that we expect in our life. So expectation also is such that any interruption or disruption in this infrastructure can create a lot of problems for the administration, as well as, of course, the people who are managing those networks and deploying those networks. So if you look at some of the newer use cases that we talk about, so as I mentioned, AI is now playing a big role in the learning process. Both teachers are using AI tools to enrich the way they teach, and students are also using AI tools to gather information more quickly, and they're also looking at a broader set of, you can say, resources from which they can get information directly via using the AI tools. And what it means for the network is that a large number of devices are trying to access these resources at the same time, so the higher density is very high. At the same time, as tools are interactive, they require the latencies to be low. And of course, the throughput has to be high in order to serve such a large number of users concurrently. On the other side, when it comes to the practical part of learning, that is through the labs and research facilities, there we are seeing greater adoption of immersive technologies through the use of AR/VR headsets, and there is a greater emphasis on experiential learning, where students can use some of these advanced technologies to conduct experiments which are almost real life experiments. So that is the other area where we are seeing a lot of changes, and this obviously requires, again, high throughput, but also very deterministic latency, because these applications or these devices require, you can say, very, very fast connections. And from an infrastructure point of view, campuses are also investing to make the infrastructure smarter for multiple reasons. One is to create a more sustainable infrastructure, and also in terms of maintaining the the physical upkeep of the buildings, the campuses. They're relying on sensors to collect data, which is then used to control the behavior of various physical systems, like temperature control, access control, and so on. And IoT devices, even though they may be transmitting small amounts of data, but they are very large in number, which means that the concurrency goes up by very big magnitude, and hence the network also needs to support these use cases in addition to the regular use cases of classroom and hostels and so on. So as a result of all these new use cases coming into the picture, what we are seeing is that the operational challenges are increasing. So as I mentioned, there is a whole set of new use cases coming in. The types of users who are accessing these networks is also changing. And importantly, the nature of devices or the kind of devices which are connecting to this network for various kinds of applications are also increasing at a fast pace. And then because of all these reasons, the types of workloads which are being used in these networks, they are also very dynamic and rapidly evolving. And as the network becomes ubiquitous, obviously the attack surfaces also expand, which means you are seeing increasing variety of threats to the network infrastructure, to the resources which are part of the campus infrastructure. So that is a big challenge that we see today. And as I mentioned, the infrastructure or the network infra is as critical as the power distribution system or the water distribution system within the campus. So any disruption in this service has serious implications in terms of the end user satisfaction, in terms of the overall network performance, and so on. While all these new challenges are coming in, at the same time, due to cost imperatives as well as the increasing use of AI in various administrative workflows, the IT teams are shrinking. So on one hand, we are increasing the complexity, but on the other hand, we are seeing that the number of people who are managing these vast, complex networks is reducing. So there is a downside there. And finally, because no one vendor can provide products which can serve all the different business cases or use cases within the campus network, so it is natural that networks will become multi-vendor. And wherever you have this kind of diversity, then you have challenges of observability, you have the challenge of manageability, and being able to enforce policies consistently, and various other issues creeping. So in summary, what we see is that while there is a strong push towards creating digital learning infrastructure, but that comes associated with a long list of new challenges that the OEMs face, that the IT admins face, and the broader industries is grappling with. So we will spend a few minutes on some of these challenges to go into more detail. So if you look at the users, broadly speaking, in a campus environment, you have three categories of users. So there is the staff, which is essentially the teaching faculty, the administrative officers, the tech and support staff, and the housekeeping staff. And then there you have students who could be living on the campus, or those who could be, just coming on a daily basis to the campus and going back. And then in any educational campus, you have regular conferences, research meets. So there is a continuous influx of visitors coming into the campus for short-term or long-term visits. So the challenge that we have is that because we have to connect all these different types of the users to the network, you must have multiple methods of onboarding these users into the network. And then because these students have a different role in the organization, the staff has a different role in the organization, and visitors have a different responsibility. So it is not okay to have the same privileges or network access available to everyone, right? So that, which means that the same physical network has to be segmented into multiple virtual networks or silos in which each of these categories of users will be put and appropriate policies applied to these sets of users so that we can control what level of access they have to the network resources. So that creates, a challenge there itself, because sometimes these the users may be crossing these boundaries. So whenever such a crossing happens, then we need to make sure that the policies are applied consistently. And there is also a requirement that, if there are faculty, for example, moving from one campus to another campus, just for research collaboration or for teaching loads, then they should not have to register afresh, whenever they move to go temporarily to another institution. So inter-institution roaming is something that is also a key requirement when we talk about campus networks. And if you look at the devices, the device ecosystem is quite broad here for two reasons. One is, as I mentioned, that BYOD is very common in campuses. So you will see all kinds of devices in terms of phones, laptops, various OSs, various vendors coming into this ecosystem. And also because of increasing use of IoT devices, you have this new category called headless devices, which also have to connect to the same network. So the challenge before us is to handle different generations of Wi-Fi technology, because students may be bringing in latest phones, and some people may have one generation older phone. Some of these devices, especially IoT devices, are still using very old versions of Wi-Fi. The form factors are different, the protocol capabilities are different. So the network must be able to support all these different incompatibilities. And at the same time, whenever we bring in or we allow legacy or older devices, they bring their inherent inefficiencies into the network, which can reflect on poor performance, not just for those set of users who are using legacy devices, but it can also impact the users who have the newer devices. So the network must be able to manage this disparity effectively, so that we don't have bandwidth hogs which are impairing the performance of others. And these headless devices pose a slightly different kind of challenge from a security point of view, because these are not human managed devices. These are typically machines, in some sense self-managed. So they also need access to the network, but they need to be verified, authenticated before they are granted access to the network. So secure access to IoT devices is a unique challenge of its own. If we look at the workloads, because of the different types of applications that are being used in this network, you will see that the workloads also vary. So for example, if you look at the productivity suite, which essentially comprises documents, presentations, spreadsheets, and other forms of documents. So there is a lot more use of online or shared applications for this kind of work now, thanks to various services that are available in the market. And then as there is greater collaboration across departments, across institutions, and between students, there's a natural need for collaboration tools like video conferencing, shared drives, and then messaging applications like email and chat. And finally, as learning becomes more tech-enabled, you have applications like streaming lectures, you have XR sets coming to the labs, and increasingly the assessment system is also moving online. So it is no more, paper and pencil or paper and pen exams. We are seeing more and more adoption of online assessment. So all these are newer workloads that did not exist until a few years ago. And the network must be able to handle these different workloads, be able to provide adequate quality of service to manage these applications, and also ensure disruption-free interactions, because all these applications are inherently interactive in nature. And finally, security is paramount. So the access to these applications and services has to be secure, has to be governed by policy controls, so that only the relevant users get access to appropriate resources based on their role in the organization. And I already talked about what impact BYOD is having in terms of the resources in the network, but it has another impact in terms of the security threats, because there is very little control on the operating systems running, which vendors are selling these devices, what security protocols they are capable of supporting, and what kind of security, you can say, agents are sitting on those devices. These are creating new attack surfaces and attack vectors, which the networks must deal with. And finally, if you look at the typical campus, it is almost like a small city. You will have residential areas, you have business areas, you have recreational areas, and there is all kinds of use cases that we already talked about. And specifically, if you look at it from a usage point of view, the Wi-Fi is getting used in the classroom, in the auditorium, in library, the lab, in the offices and hostels. In each of these different segments or zones, you find that the requirements can be different. For example, if you look at a hostel, typically a hostel room may have 2 students or 4 students, so that, and a single access point may be covering, say, 4 rooms. So the density is small, but the intensity of usage is very high. And also students tend to move around between rooms, so the mobility is also an important factor. But if I look at a classroom, there you will see that the density of users is very high, because you have 60, 80, 100 people sitting in one room, and the throughput is also very high. But mobility is not a big factor, because once the class starts, and everybody just sits there for the next 45 minutes or 1 hour. So the point I'm making is that there are various deployment scenarios to cater to, and the network design must ensure that the different requirements of each of these deployment scenarios is met, and the user experience for these different zones also matches the expectations of the user. So this kind of brings me to the second part of the presentation. We'll take a pause here, and maybe we'll take a few questions, Mansi.
Yeah, I think before we take up some questions, we have poll for the audience. I think we can go ahead with that.
Sure.
I think we are done with the poll for the audience right now.
So I can take a couple of questions before we on.
Okay, sure. You want to take the audience questions first, or?
It's up to you.
Okay.
I won't be able to read out, so you would have to read out the question.
Okay. Let's talk about the university deployment, which you have been talking about. What were the kind of primary objectives while designing the networks, and what were the challenges?
So I'll go in more detail in the subsequent slides, but what I would say is, see what the expectations for this type of network has increased, significantly from an end user point of view. So the ask is to have a highly reliable, always available, high quality network access platform. That is what the end user demands. And the biggest challenge that we have here is that the this campus that we will talk about is spread over the entire city, spread over, lots of buildings needs to be covered, and there is a lot of movement across the various zones within the campus. So mobility is an important part of the equation. And then finally, as I said, this is a campus, so you cannot control what kind of devices people come and connect to the network with. So dealing with this sheer diversity of end user devices is a massive challenge in this kind of.
Right. So, but I just wanted to understand, if an institution or a university campus is planning a total network refresh today, so what are the three most important things they should prioritize?
So, first is that the coverage. As I said, now expectation is that Wi-Fi is available everywhere. So it is not enough to provide the network connectivity in only, let's say, the teaching areas or in the labs or some isolated zones. Students expect the internet access to be available everywhere, mainly because the learning is not limited anymore to the classroom. There is a lot of exposure to resources via internet, and that requires high-speed internet access everywhere in the campus, be it a cafeteria or the hostel room or even the sports arena, right? So that is one. So which coverage is one. Second is all these new applications demand a lot of bandwidth, and typically they are very interactive in nature, which means the latencies have to be low. So the network design has to make sure that these two requirements are captured and in the design process. And lastly, I would say, like any the education institution also has to balance its, need for the best quality in, campus network versus how much money they can afford to spend on this infrastructure. So how long this infrastructure is going to last. So they have to look at the overall lifespan of the network, how much capability they have to spend, and then make the right choice in terms of what kind of equipment, software, hardware they are buying in order to serve the requirements of this network. So that's a very important criteria in this whole exercise.
Right. I think we can continue with your presentation. We are still getting questions from the audience. We'll take it probably for the session.
Okay, let's move on. So I'm going to talk about one specific deployment that HFCL did as an OEM. So most of you are aware that HFCL is an OEM for networking products, including Wi-Fi access points, switches, and controller, and also licensed band radios. So in this particular case study, we look at one institution which is more than 100 years old. It is a national level institution in India. It comprises more than 90 different colleges, and there are more than 80 academic departments, and the student population is well over 100K. In fact, in what I read a couple of days back, it was 130K, more than that. And this includes undergraduate and postgraduate students. And the unique thing here is that this is not like a campus within a boundary. So the academic and administrative and residential buildings are spread all over the city. So that's a unique challenge of its own. And some of the students also have access to residential facilities. So it's not just about Wi-Fi in the classrooms, but also we need to provide the network access inside the hostel rooms and dorms also. So what challenges, or you can say requirements that we started with? So 4 main challenges that I want to highlight. One is the scale. So scale here is across multiple dimensions. One is obviously the sheer number of users or devices that we have to support in this kind of a network. Because if you think about a student population of over 100K, even if 25% of those students connect to the network at any point of time, we are talking about 25,000 users in the network. And today, everybody has a couple of devices, a laptop or a phone. So the number multiplies as the number of devices per users grow. So that is one interpretation of scale. Second interpretation is that you have a large number of users who are concurrently accessing very bandwidth intensive applications. So there is a continuous demand for more throughput, more bandwidth. And third aspect of scale is the geographical scale. As I said, the zones where Wi-Fi has to be deployed is spread all over the city. So there is a lot of challenge in terms of trying to go to locations, trying to do site surveys, figure out where the access points have to be placed. So there is a logistical issue also in terms of how do you deploy in such a widespread area, right, where you have to basically do physical deployment at a rapid pace. The second aspect is the reliability aspect. Since this is a critical infrastructure, so obviously everybody expects that it is always available, irrespective of whether 10 people are connecting or 10,000 people are connecting. So the expectation is that the performance should be good all the time, every time, right? And education institutions are not just places of learning. These are also places where intellectual property is developed, where there is intellectual capital residing. So the security is paramount. We cannot allow any Tom, Dick, and Harry to connect to the network and access these resources. So the protection of the network resources and intellectual property is of extreme importance. And then finally, from an end user point of view, consistency of the experience is matters a lot. So wherever I am, I should be able to have a consistently good experience in terms of throughput, latency, the ease of connection, ease of roaming, and other aspects of end user experience. So these are, you can say, the four primary challenges that we started with. And from a technical point of view, these translate into some specific technical requirements. So given that we have a large area to cover, the expectation is that we should provide ubiquitous coverage across all the target areas. And given the diversity of users, the system must be able to onboard these users in a way which is simple for the end user, but at the same time, it must be secure so that unauthorized access is prevented. And it should integrate with the existing user databases, which are part of the campus IT infrastructure. And given that there is a lot of movement of people between buildings, between zones, between physical campuses, mobility is an important criteria to be addressed. And finally, if you are going to deploy such a large-scale distributed network, then you can't have visibility which is in silos. So you have to have centralized visibility so that the administrators are able to get a big picture view of the entire network from a single dashboard or console, and they can also enforce policy controls in a centralized way rather than leaving it to the local administrators. But at the same time, it also requires some level of autonomy at the local level so that some optimizations can be done locally also if required. So this is where we started the technical design, and this resulted in a solution architecture which tried to meet all these challenges in a way that we can scale well, and also we can keep the costs low. So what we designed is what you can call a template-based approach, where individual, you can say, colleges within this institution were basically had a network template through which they could rapidly deploy in their own premises, almost like a cookie cutter approach, where you could replicate this in a rapid way. And then obviously, this would get aggregated in some central core network, and the network services cannot be deployed in the edge, because then the manageability aspect comes into play. So the network services like DHCP or the network access control, these or firewall, these were centralized in order to make sure that you have good control over the dimensioning, resource allocation, and in general manageability of these critical pieces of infrastructure. And then finally, as I said, the visibility over the entire network was centralized or kept centralized in order to make the life easy for the network administrator, so that they can have full control and full visibility over this gigantic campus network from a single window. That was one important part of the network design, where we could provide a single pane of glass visibility across the entire network to this whole infrastructure. So what are the highlights of this solution? So I'll just break it down. So as I said, centralized visibility and control at scale is something that was a clear goal and objective from the beginning, and we were able to create a cloud-based infrastructure for this purpose, which could manage up to 15,000 access points from a single console. So that made life easier for the administrators. And in terms of the network services, which had to deal with a huge volume of users and sessions getting established, broken connections, disconnections, everybody, as soon as the class finishes, everybody moves out of the classroom, and suddenly you have a whole bunch of devices, moving from one AP latching on to another set of APs. So user and session management at scale was realized by deploying high performance network services like NAC and DHCP server, along with redundancy also, because it is important to have backups if your primary service fails. So not having a single point of failure was also a key design criteria. And in order to protect the network from unauthorized access, and also to have control over the traffic that is flowing through the network, we have redundant firewalls which are providing robust control over the traffic that is flowing through the network. And at the edge of the network, where the users are interacting, there we have Wi-Fi 6 indoor and outdoor access points, which are capable of delivering high throughput. They can support seamless connectivity, and very importantly, they are also capable of detecting and preventing various kinds of threats on the radio interface, which is where the attack surface is, you can say, most exposed. And then behind the APs, you have the access switches, which are not only providing the uplink connectivity, but are also powering these APs. So the switches play an important role in keeping the APs powered up and healthy. So this is the sort of, you can say, the stack that is deployed in this network. And one key point I wanted to highlight is that this whole stack is 100% made in India, developed in India, manufactured in India, and designed in India. So that's a big plus for this whole deployment. So what is the impact, right? So the impact, we can look at it in 4 different aspects. One is through this careful design and deployment and selection of various components, we were able to deploy a network which could deliver reliable and consistent quality of experience to end users, which also resulted in much higher uptake of the digital learning resources which are available in this institution. And at the same time, we were able to bring down the overall cost of the solution by leveraging indigenous components, and also optimizing on the overall the BOQ with careful planning. And as a result of deploying a centralized, intuitive, proactive management platform, we were also able to reduce the number of support tickets coming from the students and other users of the network. So that's how we delivered this large-scale campus network with HFCL access points and other network components. And what I'm going to do in the next 4 or 5 minutes is to talk about a little bit of learnings that we have from this network based on the data that we glean. So quickly looking at this is data from about a month back, 1 week data, where we were observing how the load is behaving across a week, and you can see that we have almost 7,500 access points serving this network, with the data traffic exceeding 18 TB on a single day, and consistently high data traffic is flowing through the network, and close to 50,000 unique clients connected to this network on a single day. If you go back to when I introduced this deployment, I talked about 130K students being part of this institution. And if you consider that 80% of those are coming to the campus every day, then almost half of them are connecting to the network every day. And interestingly, if you see in this graph, Tuesday, you see a dip because Tuesday was a public holiday in that week. Even then, you see that the load was substantial, which basically means that the network never sleeps. So we have to keep serving the users all the time, 24/7, 365. Right? And if you look at a smaller window, when the network is really, really busy, we find that between 12 to 1 is when we see the maximum amount of activity, and almost 50% of the total daily unique clients actually connect to this network within that 1 hour window. So you can see what is the burst size within that busiest hour. And when we design the network, it is important to make sure that we design for these bursts also, not just for the average load, because average load can be very small. If I take an average over the whole day, then maybe every AP is serving, maybe only 10 clients. But if I look at the peak load, then the peak load can be really, really high. So the network must be designed for sustaining the peak loads. And from a spectrum utilization point of view, we see that majority of the clients are actually connecting on the 5 GHz band, which is good news because that is where you have a lot more spectrum. So the loading is very good in that sense. But you also see a fairly significant usage of 2.4 GHz radio band. So there's still time before we turn off the 2.4 GHz radio. But at the same time, what we believe is that this also makes it clear that the 6 GHz band is really crucial for the industry to be able to handle the increasing load on the Wi-Fi networks in the 5 GHz band, because this will get choked very soon. And one interesting data point that I was able to get is when we looked at the top 10 APs in terms of the number of clients which connected on a single given day, and the top 10 APs with the maximum amount of data transacted on a single day, these turned out to be two mutually exclusive sets of devices, which basically means that the APs with the highest client count don't necessarily carry the maximum amount of traffic. And that may be true because in many areas of such campuses, there is a lot of transient population. For example, if I go walking through the corridor, if I'm in an office, people keep coming and going into the office. So you naturally expect a higher number of unique clients connecting. But if you're in a classroom or in a library, then typically you are sitting there for long periods of time and you tend to consume more bandwidth. So what we could infer is that the classrooms and the libraries are really where the action is in terms of the amount of data that is getting exchanged within this network. And also, even though there is a large number of APs deployed in this network, the load is not even. And that is also expected because you don't have the same amount of footfall, the same dwell time everywhere. So it is natural to expect that the load will vary across APs. But we do see almost 35% of the APs are carrying the bulk of the traffic. And there are a small number of APs, 5%, which are carrying more than 10 gigabytes of data every day. So there is a significant proportion of access points which have to do the heavy lifting day by day. So that is something that is quite obvious from these graphs. And one other learning that we have is typically when we look at network design, we always think that the traffic is primarily on the downlink. But because of these applications that we are dealing with today, the interactive nature of these applications, we are seeing that the uplink traffic is a significant part of the total load that is generated in the network. Like this graph shows that there are more than 30% of the APs have a significant fraction of traffic which is going upstream. And there are, a large number of APs where the uplink traffic is actually more than the downlink traffic. So the network designers have to look at it in the sense that, symmetric traffic is what we are seeing more often. In fact, the asymmetry may go in the other direction now. Earlier, it was heavily tilted towards the downlink. Now it may start tilting towards the uplink. So design has to take into account this distribution also. And finally, on the mobility part, we see that there are users who move very frequently, although the majority of users are slow moving or they don't move that often. But the network has to cater to both types of users. So in that sense, the robust mobility support is required across the network in this kind of deployment. So what did we learn, in this exercise through the data that we have collected and how we deployed and what challenges we face? So I'll quickly run through a few slides here. So one is, in general, of course, RF planning is good, but when you are deploying network at such a large scale, the margin of error is very small. So you must make sure that you invest in physical site surveys. You understand where you're going to deploy the network. You make sure that the RF design considers the specific requirements of each scenario. You take into account the mobility. And even after deployment, you must validate, because whatever you are doing in RF planning is basically a prediction. And you have to make sure that the prediction is accurate by making post deployment surveys. And sometimes we see that because of various reasons, people deviate from the planned deployment, and that can create performance issues, because the height and orientation and the location of the AP matters a lot when it comes to RF performance. So following the RF design as closely as possible is of great importance. And I briefly touched upon the utilization of 2.4 gigahertz band in this network. But generally speaking, it is important to have 2.4 gigahertz radios on because they ensure backward compatibility, but they can also lead to suboptimal network performance. So care is required to figure out what is the correct set of radios and the TX powers to be employed in order to ensure good 2.4 coverage without creating performance issues in the network. And SSIDs are really the way you start creating these virtual networks that I talked about, right? That's a starting point. So it is important to design the SSIDs carefully because first you need to segment the network into virtual zones for different types of users. And also because every SSID you add creates a RF overhead and also adds to the confusion for the end user. So you need to make sure that only the minimum number of required SSIDs are created and deployed. And if you need any temporary SSIDs, you can have on-demand SSIDs created and taken down as per the requirement. From a networking infra point of view, sometimes we overlook the importance of the PoE delivery from switches, but it is important that the switches deliver stable power to the access points, and there is enough headroom in the power budget calculations so that the switches don't go into PoE overload and cause instability in the APs. And the reliability of the WAN link or the link from the AP, the switch is important because frequent flapping of these links can lead to AP instability, which can create problems from a connectivity point of view with respect to end users. And we often have this debate about multi-gig versus 1 gig. In general, I think one gig interfaces are adequate for most requirements, especially considering the kind of use cases we talked about. But from a future proofing point of view, if you're looking at having running this network for the next 10 years, then probably multi-gig is a good idea, because after 5 years, you may be upgrading your APs to the latest generation, which may require higher bandwidth. Then coming to the way the users interact with this network, whenever we are designing the onboarding flows, first is they should be designed very early, because they can impact the overall network design, the end-to-end design. But from an end user point of view, the number of touch points or the amount of friction that you introduce in the onboarding journey can really put off users from using this network. So it is important to balance the simplicity of the onboarding flow with the security requirements that you have. And on the network infrastructure side, the core services that we have, like DHCP, AAA, they should not become the bottleneck. So if you look at it from the point of view of, how do you handle mobility, how do you handle randomized MAC addresses, and so on. So dimensioning must take into account these factors also. And finally, centralized management is a no-brainer in this case, because you have such a large network, and being able to manage and control this from a single point is simply the best way to do this, right? And you can do policy enforcement easily. You can push policies everywhere with a single click. So that's the best way to go. And I think one note of caution on, sometimes we go overboard when we are configuring alarms. It can create, a tremendous amount of noise in terms of network monitoring, and also creates fatigue, what we call as alarms fatigue. So only use alarms more judiciously and set sensible thresholds, so that you get to know about things which really demand your attention, rather than clogging your network feed with unnecessary information, which is, not really actionable. So with that, I conclude. Just to recap, we talked about how networks are evolving, how the use cases are changing, how the requirements of campus networks are different from the typical enterprise networks, and how the solution design and deployment must consider and balance different requirements, both economic and technical, as well as from a sustainability point of view. That's all from me. Thank you. I'll hand it over to Thiago.
Thank you, Nadeem, for such an extensive presentation. It was really helpful. Now, may I invite Thiago to present his views from a global perspective?
Yeah, thank you, everyone, and thank you, Nadine, for the excellent presentation. Really good to see all the advances and the requirements for the smart campus networks that, as you mentioned, is a very demanding environment. So before I jump into my presentation, let me just put full mode. So I just want to introduce myself. So as mentioned before, I'm Thiago Rodrigues. I'm the CEO for the Wireless Broadband Alliance. More common to just say WBA. So WBA is a global nonprofit trade association. We have members on the alliance from all over the world. And we have a very diverse membership. Of course, focusing on Wi-Fi, but it goes beyond Wi-Fi and covers other wireless technology. So we have members like HFCL, Cisco, HP, Aruba as large Wi-Fi centric houses, but as well carriers like Reliance Jio, AT&T, British Telecom, and many others, and as well enterprise companies. So companies like General Motors, Honda. We have as well retail brands like Zara, and even municipalities and other players. So the WBI, we run a series of technical programs and standards for the industry, and one of the standards that we run is this open roaming technology. So the case for open roaming is really to improve and give a fully automatic and secure Wi-Fi experience when we are moving from different public locations, including universities, but it can cover coffee shops, hotels, train stations, stadiums, any location that we can have access as consumers. The technology behind open roaming is to build a roaming federation that enables this automatic and secure experience that works on top of a technology that is called Passpoint or Hotspot 2.0 that has been around for more than 15 years. And the idea is to create that fully automatic experience. And for that, we need a framework that covers both technical and legal requirements. And our objective is to bring together two different sets of players. By one side, we have all these different networks. It can be university, hotels, airports, train stations, restaurants, coffee shops, stadiums, and so on. And by other side, we have many identity providers. So it can be an operator, but it can be a retail brand, can be a brand loyalty program, can be an internet social media network. It can be even a device manufacturer. So anyone that has information about us as consumers. And what we want to do is to transform those identities in Wi-Fi identities that can be recognized in multiple Wi-Fi networks. If I can make an analogy, our goal is to build something similar to the Visa card. So if you imagine the Visa card, we can get the Visa card from any bank, and then we can go around the world and we can utilize that Visa card that is recognized by multiple points of payment. So on this open roaming standard has been widely adopted by the Wi-Fi AP OEMs. So you can see many brands, like I mentioned, HFCL, HP, Cisco, Ruckus, Huawei, and many others. These technologies as well adopted with the majority of the devices that are available. So devices like iOS and Google Android, they support it, but as well Microsoft and many others. Even more industrial devices like Zebra is a good example of device OEM that provides open roaming services. And then just for you to understand, anyone can provide identities for open roaming technology. And some examples is, for example, Google Pixel phones, they deliver by default out of the box already an open roaming ID, or any Samsung device, they provide as well out of the box an open roaming ID. But as well, for example, for the education vertical, EduRoam, that is a large federation of universities that provide Wi-Fi, so they provide as well an open roaming identity. To understand where open roaming is deployed, we have a crowdsourcing open roaming map, so it's available to the public, so any of you can go to the internet and search. So I dropped there the link, the URL for that, so just go to wballiance.com/open roaming maps. So this is a crowdsourcing capture of locations where open roaming is available. As you can see on the map, countries like US, Japan, Europe, they have been very well supportive of open roaming, but we are starting to see countries like Australia, Brazil, and others starting to having more and more deployments of open roaming. If you guys have time and are curious about open roaming, you can jump into this map and drill down on all these dots that are on the map, and you will see some examples of deployments. So all these names, by the way, are on the map. So healthcare has been a very strong vertical for open roaming. So hospitals are really focusing on delivering healthcare services and should not be worried about troubleshooting Wi-Fi. So open roaming helps a lot on that because open roaming delivers that fully automatic and secure experience. So has been a key driver for adoption on that vertical. Another very strong driver for adoption is retail. So brands like Zara, Safeway in US, Simon Malls in US are strong believers of this technology. And many times they use it to make the life of their customers super easy. So there is no manual intervention when you utilize open roaming on Wi-Fi. And basically, they just want their customers to enter their shops and get connected completely automatically. Many times they deliver the credentials or the identity through the apps that they have. So they request the customers to download the app, and then they provide the identity that attached to the open roaming Wi-Fi network. Municipalities across the world, in particular in Japan, with more than 30 municipalities deploying open roaming, really focusing on tourists connectivity, but as well for people that move from city to city that can get connected. Education, as Nadine mentioned before, a seamless connection in university campuses is a key element of differentiation and facilitate the lives of all the students. And as Nadine mentioned as well, some of these universities are really large. They have multiple buildings and sometimes more than 50 buildings across a very vast area. So it's very important that we have this automatic and roaming, or I can move from building to building without going through over and over again through a captive portal to insert my password. So open roaming can deliver all that fully automatic experience. So universities in Netherlands, UK, US, and others have been deploying open roaming. And then we have a very diverse of other examples, like, for example, Fira Barcelona is a very large convention center. AIDA Cruises is a large European cruise ship provider that they have a vast fleet of cruises. London Stadium, where the Olympic Games in London took place. But even things like musical festivals or even the World Expo in Osaka, they all deployed open roaming to facilitate the life of all the visitors when they want to attach to the Wi-Fi. And with this, I just want to thank you all for your attention. And if any of you is interested in open roaming, would like to know more, just feel free to connect with me on LinkedIn, and I'm open to answer any questions that may come up on this webinar. But if we don't have time, more than happy to respond on LinkedIn on any questions that you can make. So thank you, everyone.
Thank you, Tiago, for again such an awesome presentation. So we have a couple of questions from the audience. So Nadeem, if you can switch on your camera. Yes, you are here. So the first question is, how would you handle scaling BYOD onboarding? For example, 5,000 new student devices each fall while ensuring network security and preventing radius server overload.
So typically in campus networks, whenever new students join, they register with the university or wherever they are starting off. So the universities create a database of users, and there's a database which is used to authenticate these users whenever a new set of users come in. So there is a natural process, same like, when a new semester or session starts, you see one batch leaves, another batch comes. So this becomes part of the academic process itself to onboard new types of users or new sets of users when the new session starts. And AAA systems are designed to handle this kind of.
Okay. Also, for campus-wide Wi-Fi deployment in educational institutions, which option is typically preferred? A managed Wi-Fi service provider or a system integrator? As an OEM, what approach would you recommend and why?
There are both are prevalent in India at least. What we have seen is the public institutions, that is the government-funded institutions, typically go with this SI-based model where they procure the equipment and get it deployed by the system integrator supported by the OEMs. That is also to do with how the procurement process works in the government. So there are certain considerations there. But we also see that, especially in the private institutions, that people are buying this kind of managed service or rental models where you can take a service for 5 years. And increasingly in the industry also, you are seeing the emergence of newer players who are providing this network as a service model. So there is a new segment which has opened up in the industry called the NAS segment in the Wi-Fi industry, where you are seeing more adoption of this. So I think based on what the business case is and what is appetite for expenses, how much capex people are willing to spend, the choice primarily is driven from that. How much as an OEM we are neutral because we provide the infra, and it doesn't really matter whether it is a capex model or OpEx for an OEM.
Yeah, can I just complement with one comment?
Yes, sure.
I agree with everything that Nadine said, and what I see on the field is that normally very large universities, they have their own IT teams, so they are more on the procurement side. They do these large tenders to request to the OEMs to provide their equipment, and they manage by themselves the infrastructure. But by the other side, smaller universities, they tend to go with the more managed services or NAS services that are becoming more relevant now.
Right. So there are a number of questions on, cyber threats and network security, being handled in Wi-Fi deployments. Probably both of you can share your comments on this.
So let me go first. So I think, as I mentioned, that there are two things here, right? One is the device ecosystem, which is part of this network, is very, very diverse. So which inherently creates more room for exploits. That is one area where being able to detect these threats at the edge itself before they enter the network, that is where robust authentication is very important. And second is there are malicious actors who will try to disrupt your network. So being able to detect such threats while you are serving legitimate users is also an important part of the solution. That's where the wireless intrusion detection part comes in. And then you have the perimeter security postures also. So there are various mechanisms which are available within the network infrastructure to be able to address the emerging threats. But also, I would say, every day we hear about a new threat. So the key is to stay on top of what is going on, who is trying to, breach you. So as long as you are agile, you are vigilant, you'll be able to tackle it. So that's the important part. So that's why 24/7 monitoring and the use of AI to analyze anomalies and detect these threats very quickly becomes really important.
Yeah, I totally agree. I just want to add a little bit more color from the open roaming perspective, especially on the authentication security. So when one university or a Wi-Fi network starts to adopt this type of technologies, that there is no password, no username visible to the user, so everything is completely encrypted. So it takes the experience to a next level of security. So between the device that has a credential that we as consumers, we cannot read it, we don't know any codes there, we just know that we have a piece of software that is given by a trusted entity that allows me to attach to the Wi-Fi, and all the path between the device and the center of the network is encrypted with, in this case, with different technologies like 802.1x and IP type of authentication methods, gives a very interesting security level for all of us when we use these, let's call them random networks on our daily lives when we go from motels to universities to coffee shops and restaurants.
Right. So we're just running out of time.
If you allow me, I want to answer one question from the chat.
Okay, yes. I was about to ask one question which I found it very interesting.
Okay, then you go first.
Okay, thank you. So, and it can be answered by both of you. It's so one of the person has asked, do we get more benefits by using LEO satellites whether it will be a game changer for good networks. So I thought
that is a question I wanted to answer. so there's a related question on 5G also. So I'll give you an answer to both the questions, right? So, I mean, the bottom line is that no single technology can solve all the use cases. So every technology has a particular application for which it is designed. So whether it's a LEO satellite-based internet or 5G-based enterprise, there are use cases where they fit very well, and there are use cases where they don't fit very well. The same true for Wi-Fi also. If I put Wi-Fi, to provide vehicular connectivity, it will fail because it is not designed for that purpose. So my short answer to both those questions is that LEO satellite-based connectivity and 5G-based enterprises, they have use cases, and people have demonstrated that it works in those use cases, and they will be around. So they will complement Wi-Fi. So no single technology can solve all the problems. That's the short answer to both the questions.
Yeah, I totally agree. And what I want to say is in WBI, we have a very vast program of convergence between wireless technologies. And we have very large carriers, including, for example, AT&T and Geo and many others, looking to how can we have intelligent management of all these wireless technologies. Probably until now was just between Wi-Fi indoors and cellular outdoors. So there is a series of techniques that can evaluate the QoS between cellular 5G or cellular 4G and then Wi-Fi. When should I offload from cellular to Wi-Fi and vice versa? But now, as Nadine said, there is a new kid on the block that is special, the LEO constellations that are bringing another element. And I think that convergence will become a little bit more complex, but I think the industry will handle very well. So all of us, I'm pretty sure that in a short period of time, we can benefit from cellular as usual, Wi-Fi as usual, mainly indoors, and then in very remote areas or areas that have gaps on cellular coverage outdoors, we can take advantage of LEO as well.
There's one last question, I think specifically for Tiago, if you would like to answer. Beyond students and staff, how does open roaming handle the growing number of IoT devices on campus, like smart building sensors, digital signage, lab equipments?
Yes, that's a very interesting question. We have in the WBA, we have a work stream specifically for IoT on open roaming networks. Because at the end of the day, open roaming utilizes one identity that is unique to each device. If, for example, I'm Tiago, if I have two devices, I will have two different identities, one on my smartphone, maybe one on my laptop, maybe one on my iPad. And we have a work stream for IoT. So we are testing right now with several type of sensors, can be cameras, can be speakers, can be any other type of IoT device, special devices that don't have a user interface. So that to all of us, we can experience on our lives when we buy, for example, a speaker, that there is no user interface. How do I attach the speaker to my Wi-Fi network? And our goal is to build, and we are testing that at the moment, to build a system that I can buy any endless device. I can bring it to my home or to my company or to my network or like an university, and that device will be recognized by the network, because as by default, one open roaming identity embedded. And by having that embedded identity will facilitate a lot the onboarding on the network.
Great. The questions are still, coming in, but I think in the interest of time, we'll just wrap it here. Thank you so much, Nadeem, and thank you so much, Tiago, for such an interesting session.
Thank you, Mansi, for hosting this.
Thank you, everyone.
Thank
you,
you,
everyone, for listening. Bye.